Hello everyone, welcome to the 13th episode of the series. In this video, we'll talk about the general formula for determinant computation and the rule of Sarrus for 3 by 3 determinant computation. So far in the determinant mini-series, we've learned about the basic properties of determinant of a matrix, and we've also learned how to use row operations to turn any matrix into an equivalent upper triangular matrix and compute the determinant there. And in this video, we're going to look at the general formula for determinant, which is not really practical, but we're going to include it for the sake of completeness. And we're going to look at the rule of Sarrus, which is a method for computing the determinant of a 3 by 3 matrix. So if A is an n by n matrix, then the determinant is given by this formula, where the sum runs over all possible ways to rearrange the numbers 1 through n. We call these rearrangements permutations of 1 through n. And S of P is the number of pairs ij in this permutation P, such that I is less than j, but the number in the permutation Pi is bigger than the number at position j, which is Pj. So for the purpose of illustration, we are going to look at the following example, where we're going to try and compute the determinant of this 3 by 3 matrix using the general formula. So since this is a 3 by 3 matrix, we list all permutations of 1, 2, 3, and there are going to be 6 permutations. Please feel free to check that there is no other way to rearrange these 3 numbers. So for the sake of demonstration, we are going to work with the permutation 2, 1, 3. So corresponding to this permutation, there's a term in the sum, in the determinant formula of the form -1 to the SP, A21, A12, A33. So we go to the matrix and we pick exactly those terms. So A21 is 3, A12 is -1, and A33 is 8. And S213 is just 1, because there's only one pair, I equal to 1 and j equal to 2, such that when I is less than j, Pi is bigger than Pj. In other words, when we look at the permutation 2, 1, 3, there is only one pair when the position number and the value of the numbers themselves don't increase together. So at position 1, we have the number 2 here, and at position 2, we have the number 1 here. So in this pair, my Pi is 2 and my P2 is 1. And there's only one pair like that. And therefore, my S of 213 is going to be 1. And therefore, this term in the sum, in the formula for the determinant becomes -1 to the 1 times 3 times -1 times 8, and that's 24. Now that's just one term in the sum. We have to do it for all permutations, so we have to do it 5 more times and then add them to find the determinant. Now this is clearly not practical, because for a 4 by 4 matrix, you would have to do it 24 times. So in practice, there are far more efficient methods. So the next thing I want to talk about is the rule of Sarrus, and it only works for a 3 by 3 matrix, but it's worth knowing about. So this is often used in the cross product of two 3-dimensional vectors. So if you have a matrix given by A, B, C, D, E, F, and G, H, I, and you want to compute its determinant, it's just given by this formula. This is how the rule of Sarrus works. So we copy the first 2 columns to the right of the matrix. So we take the columns A, B, G, and B, E, H and make copies of it to the right of the matrix. And then we draw the 3 possible diagonals. Along each diagonal, there are 3 entries. We take their product, and then we add all the 3 products with each other. And then we draw the 3 anti-diagonals Each anti-diagonal has 3 entries. We take their product, and then we add the product, we multiply that with a -1, and then we add it to the first sum that we found here, and that tells us that we get the same formula as this. So the sum of these, is the determinant of the 3 by 3 matrix. Okay, so let's look at an example. So we're given a 3 by 3 matrix given by the entries 1, 2, 3, 4, 5, 6, 7, 8, 9, and we want to compute its determinant using rule of Sarrus. So we do what the trick said. We copy the first terms and we place them to the right of the matrix, and then we look at the 3 diagonals. Each diagonal has 3 entries. We take their product, so we get 1 times 5 times 9, 2 times 6 times 7, and 3 times 4 times 8. And when we multiply them and add them, we get to 225. And then we draw the 3 anti-diagonals. Each anti-diagonal meets with 3 entries. We take the product, we get 7 times 5 times 3, 8 times 6 times 1, and 9 times 4 times 2. We multiply it with the minus sign, and we get minus 225. And the determinant of this original matrix is 0, because it's supposed to be the sum of 225 and minus 225. And with this, I would like to end this video. I'm hoping things are clear. I will see you guys soon. And until then, happy learning.